Hi everyone, so welcome to the first video, which is going to be on calculus optimization. I have this question here. It's pretty old, but it's a pretty good question. I'm going to see if there's a way for me to link the document where I'm getting all these questions from, probably through Google Drive, and then if I can, it will be in the video description. Also, if you have any requests for something I should focus on, or something in particular you'd like to see, just put it in the comments, and then I might be able to get to it after making those videos that I plan to make. So in this question, we're given a graph of f of x cubed plus y squared is equal to 8, right? So it tells us that this graph is between x, 0 and 2. So this must be 2 over here. Okay. Then it tells us that p x of y is a point on the graph. So it's talking about this point. Awesome. So now if we have to just get a y-intercept over here, you can substitute in x equals to 0. So if this x equals to 0, then this would be y squared is equal to 8. And so in that case, we square root the 8. We square root the 8. And so we're going to be left with y is equal to 2 square root of 2. Okay, so that's this. Okay, so 2 square root of 2. Awesome. So determine OP squared in terms of x and y. So OP squared, if you can tell over here, this is a radii. So OP squared is just going to be x squared plus y squared. Cool. Also, I'm writing on a tablet, so if you can hear I'm sorry. It's just the way it is. It's just what I'm writing with. Sorry guys. Then 1.2 is show that OP squared is equal to that. So we know that OP squared is equal to x squared plus y squared, right? But we know that we know that the function is x cubed plus y squared is equal to 8. Okay, and so what we can do is we can take the y squared to the other side, to this side, and then take the x cubed to the other side, and it becomes negative x cubed plus 8, which is equal to the y squared. And so we're going to basically just plop that into here, and we'll be left with x cubed minus x cubed plus 8 is equal to 8. Okay. Yeah. Oh no, sorry guys. No, you're supposed to put this into here. Slow start, sorry guys. I'm warming up. Let me cook. Okay. So, yeah. We're gonna put this y squared inside of here. Cool. So OP squared, because that's what we're obviously solving for, it will be x squared minus x cubed negative x cubed plus 8. And then that's pretty much what you have there. I'll just rewrite it so that it looks pretty. There we go. Okay, let me just move this down as well. Awesome. Then 1.3 is determine the maximum value of OP squared. Okay, so whenever you're looking at maximum or minimum, you're always going to have to derive. I can promise you that now, you're always going to have to derive. Okay, so what you could do is you could substitute in x and y values into the function. Okay, like this is the manual way, and then get x and y values, and then from there use this OP formula to get the length of OP for those various x and y values, but that would obviously take you literal hours. It would take you like forever. So that's not what we're going to do. What we are going to do is we are going to make this OP squared f of x. Okay, and so that means we'll be left with this. Then we're going to derive this f of x, and we're left with negative 3x squared plus 2x, and then the 8 falls away. Okay, now whenever you're solving optimization questions, you pretty much just need to make this equal to 0. You pretty much just always are going to make this equal to 0. And I'll show you like the mathematical reasoning behind that. Just let me solve this. Make that equal to 0. So the 0 is going to be equal to negative 3x squared plus 2x. Here we're going to factor out the x. So we're left with negative 3x plus 2. Therefore, x is equal to 0, or x is equal to, what's that? Negative 2 over negative 3, so that's just 2 over 3. Cool. Cool. And then I'm actually going to move this like very far down. Awesome. Okay. Now, in terms of determining those maximum values of OP squared, we have our equation for OP squared over here, which specifically doesn't have any y values. You don't want any y values because that brings in another variable that you would then need to optimize for, which you guys haven't been taught, so yeah, we're not going to go there. But here we're just going to basically put f of x equals 0 and f of x equals 2 over 3 into here. So if you substitute 0 into here, you'll get 0 plus 8, so it's just going to be 8, right? If you put 2 over 3 in here, you will have, I promise you, if you substitute it in, you'll get 8.15, okay? And so you can see that then the maximum is going to be where x is equal to 2 over 3, and the maximum value of OP is then 8.15, okay? So, yeah. Then for 1.4, the question asks us to calculate the shortest distance from the origin to the graph. Okay, so I'm going to give you a very extreme drawing here, but basically functions in general like this that form semicircles, well, quarter circles in this case. Okay, very extreme example. They almost go like this. Okay, so again, that's a very, very extreme example, but you'll always find, okay, this obviously isn't drawn to scale, but this length at the bottom here or at the top here will always give you your lowest values. Excuse me. And then the point to the very like middle of this arc is going to give you your maximum. Okay, so that's something you guys should know. But to prove it, I'm just gonna take a few x and y values and then we'll put that in. Okay, so the shortest distance from the origin to the graph, we can see this is obviously a quarter of a circle, and so we can use the radii formula, which is just this, technically just this OP squared formula. So the distance we'll call d, even though it's technically r, squared is equal to x squared plus y squared. Okay, so your x and y values obviously have to still fit onto the graph, else you're not answering the question. So our graph is x cubed plus y squared is equal to 8. Okay, so if we have x1, for example, x1 cubed plus y squared is going to be equal to 8. So then our y value would be y squared is equal to 7. So y would then be the square root of 7. Okay. Oh, actually needed that decimals. Can I have those decimals back, please? No, it seems not. Okay, so what we get then, come on, there we go. Yeah, we want to copy that expression. Bam. Okay, useless. this Apple Maths notes, it doesn't work. Anyways, so I'm actually going to turn that off because that's so annoying if it's not even going to give me the right answer. Okay, anyways, so what we see then is that the distance here is going to be d squared is equal to 1 squared plus 7 squared. D is just going to be equal to 8. Square root of 8, which is going to be 2 root 2. Okay, I hope that makes sense. That would be like sort of just like where x is equal to 1, so like somewhere here. Okay, then another value we'll try is obviously like this bottom where y is equal to 0 and x is equal to 2. Okay, so the reason I know that's on the graph is because that's our x-intercept. Yeah, that's our x-intercept, 2 and 0. Okay, so that's what I'm going to substitute in here for in terms of distance. D squared is going to be equal to 2 squared plus 0 squared, which is just going to be, obviously distance is equal to 2. Okay, so you can see that this is obviously less than that. Okay, yeah, that's just the way a circle works. The shortest distance will always be this here. Obviously, when I'm using the word circle very, very loosely, because obviously if you're thinking of an actual circle, if you use a quarter of that circle, right, this line will be equal to this line, which will be equal to this line, which will be equal to this line, which will be equal to this line. Like they'll all be equal, right? Because obviously those are radii and all radii are equal. Okay, so I'm using circle very, very loosely. It's not actually a circle. Don't think it's a circle. It looks like a circle. It's not. Okay, it's really not. It's a function, and that's why I'm saying just in general, this function tends to